The information revolution is entering a new stage as information technology extends further, deeper, and becomes more pervasive. Made technically possible by the confluence of cloud computing, machine learning, big data structures, and the Internet of Things. Datafication and processes of computation are rapidly expanding out into unstructured environments as the programmable computers that formed the basis of the information revolution in the 20th century are giving way to a new computing paradigm where cloud platforms enable the locus of computing to move up to whole systems of people, technology, and information networks that generate huge amounts of unstructured data requiring new algorithmic approaches to interpret. Computers of the past have operated in predictable environments using structured and uniform data to perform prescribed operations. Information was relatively confined to specific places, well-structured, and limited in volume and variety. With the proliferation of mobile devices, online platforms, social networking, and the Internet of Things, we are datafying our world, turning ever more processes and activities into data. This creates a new type of data, what is called big data, that comes in massive volumes, is unstructured, dynamic, and heterogeneous. A tweet, a photo taken, an online purchase made, a barcode scanned, a web search, a flight taken, a video watched, an image tagged. All of these contain little traces of data that, when combined, can contain valuable insight. This unstructured big data is estimated at 80% of all data and gets the name dark data because it cannot be effectively processed by existing information systems. Just as the locus has moved from data to big data, computing has moved from personal computing to cloud computing. Cloud computing is the networking of many computers and the making of their capabilities available over the Internet as a service. This makes the high-end computing capacities of large data centers available to many on demand at low cost, meaning more and more organizations, systems, and devices can run ever more complex algorithms. This next generation of computer systems has to read and interpret vast amounts of unstructured data and use it to identify patterns, often in real time. It could find a certain pattern, like a house, in millions of images or videos. To analyze incoming communications, email, voice, or a social stream, or to analyze financial transactions to detect anomalies. This requires new algorithmic approaches. Unlike computing of the past, machine learning methods are largely based on data instead of logic. They use data to build algorithms. These systems use information from many different sources to cross-correlate them and reason about the meaning in the data. A cloud-based application can potentially cross-analyze millions of different data points across many different domains, creating a new kind of insight into complex systems that is currently beyond our capabilities. With these technologies, computerized systems can expand out into unstructured physical environments and interact with humans in a fluid fashion. Through connecting up more and more devices and systems to cloud platforms, computation comes to act on ever larger, more complex systems, optimizing whole supply chains, predicting maintenance on mass transit systems, routing urban traffic, coordinating electrical production on the grid. The information revolution continues. Further, deeper, faster, more disruptive.